Hey guys, this is the second one I wanted to do here, number 37, and it's another problem we can do with that regression um, style. Even if it's not calling for the words exactly linear regression in the problem, you can use these techniques. And anytime you have a linear model you need to make and you've got multiple data points like this, you can use that technique as long as it's calculator active. So the table below shows the number of hours 7 students studied for a math test and the grade each student earned on the test. Okay, so here's our 7 students. The number of hours they studied is my x, and the corresponding grades they received are my y values. Okay, now let's read the question here. How does Amanda, here's Amanda, we locate her in the table. How does Amanda's test score compare to the score predicted using the linear best fit model of data for a student who studied 3.5 hours? Okay, so what they're saying here, when you read something like this, is when you create this linear regression model, because that's what it is, it's a model, it's an equation, it will not predict every value exactly that this thing has in it. It's going to be a model that approximates these, right? And that's what they're asking. They want to know what the difference is. So I got to build this model, and I'm going to have to plug in a 3.5 into my model and see what the difference is. All right, and that difference, by the way, and we're going to see this in the next video is called a residual. Right, the further your model output that the model predicts is from the actual data value, that's called that number, that difference value is the residual. And that language is used in another problem in the next one. All right, so I've already started working on this because I don't, the time element here. And to remind you one more time of how this is done, you go to Stat, Edit, and you enter your X values into L1, Y values into L2. I've already done that. And we're going to calculate a model. Stat, again. Uh-oh, let me drag this over a little bit, if I can, without getting in trouble with it. There we go. Stat, calc, number 4, that's your linear regression, and we're using L1 and L2, and we're going to calculate. All right, so there's my model, okay? Now, what's important here is your A and your B. You're not using this correlation coefficient for anything. It's just still on from the last problem, but it could be asked in some other problems, so always turn it on. All right, so y equals mx plus b. There's my m, there's b, so I can build my model, and I've already done that on another piece of paper here. All right, so I wrote my model down. And basically what they're asking me, what does the model predict for studying of 3.5 hours compared to the actual data point? So let's see what the model predicts for Amanda, right? Amanda. So we have 5.187. So what goes in our model is study time. We'll study 3.5 hours plus the 76.518, 87. Now, I don't know if you noticed this, but I took some liberties with this thing and did a little bit of rounding here. All right, so this is, well, let's say this is approximately 94, and you would have to calculate this in your calculator, 0.67. All right, so the model predicts she should have made a 94.67. What did she actually get? That's the question. All right, so let's read these choices. We know the model's predicted around a 95. How does Amanda's score compare? So Amanda's score was a 93. So let's read these options. Amanda scored about 5 points lower than the score predicted. Well, that's not true, right? She scored actually 2 points lower than the prediction, or not even quite 2, but then we could round. Amanda scored 5 points higher, not true. So we come right down here to see either C or D because they're talking the 2 points, right? Amanda scored about 2 points lower than the score predicted for a student who studied 3.5 hours. That's true, right? Amanda scored about 2 points lower. She got a 93. The thing predicted she'd get a 95 or 94.7, I think it was. So it sounds like C, but just to be careful here, let's read D so make sure we're not getting tricked. Amanda scored about 2 points higher. That's not true. Amanda scored a 93. And to point something else out right here, the residual in this case would be 94.7 minus 93. So you'd have about, what, 1.7 or so. But anyway, the answer here is C. C. All right, see you in the next one.